Okay, that's the last stretch home here. Last speaker, Jason Bartanen. Jason is the Director of Industry Technical Relations for iCar at its iCar Tech Center in Appleton, Wisconsin. Jason leads the iCar Repairability Technical Support Initiative and leads the organization's technical relationships with vehicle, tool, equipment, product, and material manufacturers. So Jason is the technical reference, and that's Jason. We've known each other for quite a while, and absolutely always been on top of things from a technical perspective. So welcome to the CCIF, and it's all yours now.
All right, thank you very much. Thank you. Good. All right. Good afternoon. Really appreciate the opportunity to be back here at CCIF. It's been a couple of years since I've had the opportunity to talk to my great Canadian friends. My name is Jason Bartanen. I'm the Director of Industry Technical Relations for iCar at our iCar Tech Center in Appleton, Wisconsin. Appleton is known for Miller Electric. You may be familiar with their blue welding machines, fantastic equipment. And also, Appleton is the home of Harry Houdini. Harry Houdini moved to Appleton when he's around 4 years old. And a former colleague of mine has been quoted as saying that Harry Houdini's greatest escape was from Appleton. I disagree. I like Northeast Wisconsin quite a bit. I, like Dave before me, don't watch nearly as much hockey as I would like to, but I do watch a lot of curling on TSN, and I will be pulling for Team Holman and Team Cooey and Jennifer, was it Jennifer? No, who's with John Morris? John Morris is a mixed partner. So looking forward to Caitlin Laws. There we go. So really looking forward to the Olympics this year, and then watching some great curling. So maybe I'll try to fit a little bit of hockey in there as well. Every presentation I talk about, I really like to start off with the iCar vision, because this is what drives what I get to do. This really drives the RTS, the Repairability Technical Support team back in Appleton. And a lot of us have been in this industry for a long time. We really are passionate about the industry, and we really focus on that complete, safe, and quality repair for the ultimate benefit of the consumer. I think it's a very noble vision, and one that we certainly try to live our lives daily with. So I want to talk about a lot of different things here this afternoon, and we don't have a lot of time, so I'm going to be probably talking a little bit quickly. I apologize for that in advance, but I got a lot of screens, a lot of content that I want to share with you and focus in on a couple areas. I'm going to talk a little bit more about advanced driver assistance systems. I know we've talked about that quite a bit already today, and you know, it's been kind of the buzz in the industry, so I'm going to touch on a couple things that we've learned recently. I also want to talk on some advancements in steel and aluminum, some advanced joining technologies, primarily rivet bonding and MIG brazing, and then give you a little bit of information on the Repairability Technical Support Initiative, which a lot of you may not be familiar with. It's only been around for a couple of years, so I want to teach you, share with you some of the tools that we've built that you can leverage. Again, collision repair diagnostics and pre-scan, post-scan, the whole conversation around it continues to flourish in the industry. I think we're making a lot of advancements in that area. We're getting a lot of the conversations that we were having 12 or 18 months ago have kind of quieted. Now we're focusing more on the calibrations and the aiming and all the things that are required for it. So we've gotten kind of past, I think, the misinformation about malfunction indicator lamps, that if there's no light on the dash, there's no problem with the vehicle. I think that it's mostly recognized now that is not accurate. We need those diagnostic trouble codes to really identify what exactly is wrong with the vehicle, and that's where we start getting into that pre-repair scanning that can really help us identify hidden damage. It can help us identify related and unrelated damage, and ultimately potentially improve cycle time by identifying some of those issues ahead of time. So if you don't know, just like measuring, if you don't measure the vehicle, it's not possible to get an overall view of that particular vehicle and where the damage is. Same thing with collision repair diagnostics. If we don't scan the vehicle, we really don't know what we're dealing with in totality. Then post-repair scanning helps ensure the vehicles return to the customer without those DTCs. And then calibration is really a key for those complete, safe, and quality repairs. So that's another part that we're starting to hear a lot more conversation around the calibration and aiming procedures, which is very enlightening to hear. Obviously, the OEM position statements are out there on when scanning is required. But again, even if you're not following position statements, if you're just going to be repairing the vehicle, scanning that vehicle really is a benefit to everybody involved in the process to make sure that the repair plan can be built appropriately and that we're putting the customer back in the vehicle properly. So A couple of ADAS we typically talk about, collision warning, adaptive cruise control, lane departure warning. Dave was just talking about the lane keep assist, turning the car back to the middle of the road. A lot of the blind spot detection, the 360-degree cameras, and collision braking. So collision braking is going to become kind of the next big thing across the country as in 2022, North American vehicle manufacturers have all voluntarily agreed that standard equipment on 2022 model vehicles will be collision braking, that they'll include collision braking on those vehicles. This particular chart is kind of showing where collision braking is going. Where we're at today, very few vehicles on the road have a lot of collision braking, a lot of collision warning systems that aren't going to automatically brake, but there are not a lot of collision braking systems out there yet. But it's predicted by 2026 from this group that about 50% of the fleet out there will have automatic braking. And this particular chart just kind of reinforces, this one's from the Insurance Institute for Highway Safety. So again, right in that 50% ballpark in the mid-2020s. One thing with regard to autonomous vehicles with collision braking, this is a statement from the Insurance Institute for Highway Safety President Davis Harkey, who just a couple of weeks ago said that even if 100% of cars made today were autonomous, it will still take 2 decades to turn over the U.S. fleet. So I imagine it'd be very similar in Canada as well. So we've got some time yet before we can doom and gloom for the collision repair industry. Cars are going to continue to be in collisions for quite some time yet. So that's one question that does come up frequently is, what impact is autonomous vehicles going to have on the collision industry? As long as there's people driving vehicles, I think we're going to be involved in collisions. There's just another accident last week with a Tesla that the driver left it in autopilot and ran in the back of a fire truck. So it's going to continue to happen. Plus all those other vehicles out there that don't have the autonomous features are still going to be involved in collisions. What I think is going to happen with regard to the autonomous vehicles and the braking is we're still going to have collisions, but those collisions are going to be taking place at a slower speed, which I think is ultimately going to mean more repairable vehicles. So vehicles that maybe would have been involved in a 35 or 40 mile an hour collision and would have totaled today, maybe in a few years that vehicle will be involved in a 15 or 20 mile an hour collision instead, and we're going to have more repairable vehicles. Now certainly the sensors and the cameras that are on the perimeter of the vehicle are going to play a role in the severity as well, but I really do think that less of the structures are going to get damaged at some point in the future. I don't have any data to support that. That's kind of my gut feeling on it. ADAS certainly provides some challenges for us. Because not every vehicle is going to be equipped with it, identifying which system or which systems are on a particular vehicle can be challenging, especially when you've got glass that from the factory that all have the cutout for the camera, the rear view mirror camera, even if there's no camera in that vehicle. So we're going to have to start thinking about how do we identify if the vehicle's got these systems. We've been doing some work, and I'll share some best practice information that we've done with regard to that on that in just a minute. And then the next part is parts location. So where are those parts? If I identify that it's got adaptive cruise control, which sensors are typically going to be in the grille or be behind the bumper cover, well, those parts are often involved in collisions and aren't on the vehicle by the time the car gets to our shops. So again, identifying which parts are going to require replacement, how do we inspect them, how do we make sure that they're running properly. Module programming is becoming more important as well. And then the post-repair inspection, that's the next kind of hurdle I see is, okay, we've done the scanning, we've done the calibrations. How do I know if that system functions? The collision braking system is not going to brake until it's involved in a situation that requires collision braking. But how do we as collision repair professionals ensure that those systems are going to work properly? So we're going to look at developing some best practices on that as well, hold some iCar repairability summits probably in the spring to discuss some of those pieces. ADAS also provides us with some huge opportunities as well. Having diagnostic capabilities in your shop is a way to improve cycle time. I think that a scan tool is becoming an essential piece of equipment, much like a squeeze type resistant spot weld or a MIG weld or a 3-dimensional measuring. It's the next required tool to do the job. And then having the in-house expertise and having that individual that's going to be able to do all the diagnostics, do the scanning, do the calibrations, do the aiming. It's a full-time job. Maybe it's more than one person doing a full-time job. For those that work with local career and technical schools and colleges and are on advisory committees, I would encourage you to make sure that program that you work with is incorporating collision repair diagnostics into their program. I'm starting to see a few schools do that right now, but we need a lot more schools. So we have young talent coming out of colleges and tech schools that have that knowledge and have that skill. I've got a 15-year-old nephew that I think this is going to be a great career for him. He loves cars. He was one of those kids that still loves cars. He's a big Hemi fan, but he also loves playing video games. He loves computers. So I think tying those two things together is a role out there for a collision repair diagnostic technician that we really need to start grooming the future technicians for. It's going to be a very good job in the future. Okay, so calibration and aiming requirements, again, I know people have touched on this throughout the day. It's definitely going to vary by make and model, so it's going to be very important that we look through the OEM procedures to identify what exactly is required. Is it going to be a static test that we're going to have a dedicated space in our shop with, X number of meters in front of the vehicle and X number of meters behind the vehicle, and the lighting needs to be properly. It can't be too many shadows, but it needs to be bright enough. There's just a lot of different requirements. The level on the ground, you can't have more than an inch from front to back of the vehicle in some of these calibrations for the static test. So having an area in your shop, much like the aluminum clean rooms that we've talked about, I really think we're going to have a calibration, a collision repair diagnostics room in the shop of the future, where we're going to have our scan tools, we're going to have our targets, and we're going to have that young, skilled technician that understands these systems and can troubleshoot them and repair the vehicles and put them back on the road properly. Dynamic testing, so taking the vehicle on a road test, like a lot of the lane departure warning systems, lane keep assist systems, require you to drive the vehicle for a set amount of time, so that so that new camera can kind of learn where the markings are on the road. And why it's so important with these calibrations and aiming is, the cameras themselves are just cameras. It's looking for those markings on the road, and if it's turned one way or the other, a degree or two potentially, if it's always pointing at the center line, it's always trying to steer the vehicle back, you're going to have some customer complaints, you have some tire wear issues potentially. Conversely, if it's pointing towards the right side of the road, it might be trying to push into traffic continuously. So it's important that we aim these systems. Same thing with the adaptive cruise control. If it doesn't see the vehicle in front of it, it doesn't know how to react. So it's very important that we do this. The dynamic testing, the static testing. Some vehicles are going to require both a static test and a dynamic test. Others require just a static test. So again, it's going to be imperative that we go to the vehicle service information and find that information and make sure that we're following the procedures properly. Again, scan tools are going to become an essential part of the equipment, and then we may need some special tools and equipment as well. So here's an example of the Honda kit. So the Honda aiming kit for a lot of their advanced driver assistance systems. Some PVC pipe, some plumb bob there to find the center line of the vehicle, measure out this proper distance, and then set the targets up at their proper height and proper distance. Again, you're teaching that system, this is what X number of meters is in front of it and height-wise. So again, that system knows how to interpret other vehicles that are there. So same thing with like a lot of the active park assist, where that parallel parks for you. If we don't calibrate those systems properly and it thinks that 1 meter is 5 meters, and next thing you know, you're backing into another car, because again, that sensor doesn't know that the actual distance is 1 meter now and needs to start braking on the vehicle. Here's some more calibration. This is Ford's for their 360-degree mats. So the 360-degree cameras aren't necessarily as much of a safety thing, but if you don't calibrate those cameras properly, you're going to have a gap in coverage, or you're going to have an overlapped image. So again, calibrating with these calibration mats would be required. Again, that's more of a customer satisfaction issue right there. I mentioned some best practice that we developed on advanced driver assistance systems. These are available at rts.icar.com. These are available to the Canadian market as well. On the left-hand side there, you'll see a best practices link. Click on that best practice. In addition to the ADAS, we've got some MIG brazing information. We've got a best practice on recycled outer quarter panels with rolled hem flanges. So we've got a lot of good information on there, so check it out. These are inter-industry developed and vetted best practices. So this wasn't just Jason and a couple people from Appleton sitting down and say, hey, what should we put on this? This is bringing subject matter experts together to discuss these issues and develop these best practices. So again, these are we just published them. So these are inter-industry developed and vetted. We've got one on definitions. There was a lot of confusion on what's a pre-scan, what's a post-scan, what's a health check, what's a calibration or an aiming procedure. So we've developed some definitions to try to get the industry on the same level. We've also developed one on the best practice for actually going through the diagnostic process and when to scan the vehicle, when to look for the information and follow through that. And then on the last one that we've got on ADAS right now is our best practice for damage analysis. So walking up to the vehicle, looking at the vehicle, and trying to identify what it's got. We held a repairability summit at Aztec to develop this best practice, and we had a late model Mercedes GL, I believe it was, and we had the audience get up there of a lot of these thought leaders in the industry and go and walk around that vehicle, and we all came back together. I said, okay, what's this vehicle equipped with? Does it have automatic braking? Does it have adaptive cruise control? It was, again, we're looking for something completely different than just the collision repair damage on it. Now we have to identify if it's got these systems. So we've got a best practice on how to identify some of these systems. Again, a lot of these industry leaders, they weren't aware. They didn't know what they were looking for on these vehicles to identify. So again, we're trying to teach that thought process of going through the damage analysis process, identifying which systems it has, identifying which parts require replacement, replacing those parts, calibrating, aiming them, clearing codes, test driving the vehicle. All right, another tool that's available to the industry is our OEM calibration requirement search. This is, as far as I know, a one-of-a-kind tool. We've got coverage for 2016 and 2017 model vehicles. We're looking at bringing on some additional staff right now to the RTS team to go back and look at 2015 and 14s and add some new features to this. But what this we've literally got thousands of hours into the development of this calibration search. So you can look for a make, model, and year of vehicle, and I pulled up a Honda Civic here. It's one of the vehicles that we've got in there. So we spent thousands of hours, so we can say the industry tens of, if not hundreds of thousands of hours every year. To find this information can be very challenging, to try to find out every system on the vehicle and which conditions necessitate a calibration or an aiming procedure can be very complex. So we've taken it upon ourselves to do a lot of that research on behalf of the industry so that when you're developing that damage assessment, when you're putting together your repair plan, you can identify, hey, we're replacing the glass on this vehicle. It's required that we recalibrate the lane departure or lane keep assist system, the camera on this vehicle. So again, you can build it in the repair plan. This tool will help you get there. So if I click on 2016 Honda Civic, the first screen you're going to see is going to be a login screen. This is primarily for our U.S. customers. They have to log in with their My iCar username and password. But for Canadians and for our Australian and New Zealand iCar folks as well, on the bottom, let's go back here. It says, if accessing this site from outside the United States, click here for limited access. The majority of the RTS portal is available to international customers. There are some things that aren't available. Some of our Ask iCar features, the ability to pick up the phone and call our staff isn't necessarily available. But the majority of the content on here is, you click on click here, and then we're asking again, confirm that you're a non-U.S. resident. At some point, we'll probably tie this to IP addresses so that we don't have Americans trying to log in this way. But because we don't have any student data in our system in the U.S., we wanted to make sure there was a way for our Canadian friends to get access to the website. So that's how you get there. So I've pulled up my Honda Civic. And what this tool does, it tells you which vehicles may be on this vehicle. These are the options that are available for the Civic. So and it's not a comprehensive list here, but this vehicle is available with adaptive cruise control. It's available with collision braking. It's available with side view. It's got blind spot. So all the different systems that it might be equipped with will be found here. Now, it doesn't necessarily mean the vehicle you've got has those systems, but that it may be an option. Then you need to start going through your best practice of identifying, okay, how do I know if it's got these systems? The next part we talk about is which cameras and or sensors kind of power that system, and the location of them. So for example, you can see here on the adaptive cruise control, there's a camera on the rear view mirror, and there are sensors behind the front bumper or grille on the Civic that manage that adaptive cruise control system. We'll also let you know that does this particular vehicle set a diagnostic trouble code if there's an issue with the system. In the case of the Civic with the adaptive cruise control, yes, it does. And also whether or not a malfunction indicator lamp will come on. Again, the Civic in this particular example will have a MIL that will come on if there's an issue with the system. So the Toyota Camry that we talked about last night does not have a MIL for the adaptive cruise control. So again, knowing which systems do and don't turn on MILs is good information, but certainly not the evidence that there's nothing wrong with the system. So if I click on camera in rear view mirror, what it's going to do is going to jump down a little bit lower, and it's going to tell us what they call it. So Honda calls their camera on the rear view mirror the multi-purpose camera unit. Now, why that's important is as you're going through the service information, you can now do a search for multi-purpose camera unit. Rather than doing a search for adaptive cruise control or mirror camera or whatever, we'll give you the OEM name to make it easier to find that information in there. And then we cover the events that necessitate a calibration for that. So for this one, calibration required is if the multi-purpose camera unit is removed or replaced, the multi-purpose camera unit must be re-aimed. If the windshield is removed or replaced, the multi-purpose camera must be re-aimed. So even if we get that stone chip and we have the glass people come out and install it, that camera still needs to be calibrated. Even if we didn't touch the camera, for this particular vehicle, that needs to be calibrated. We've been working with the Auto Glass Safety Council as well, trying to share this information with them. Their heads are spinning as much as ours were a couple of years ago. Fortunately, they don't have to deal with the stuff in the windshield, but it is very important that we share that with our glass installers as well. All right, steel advancements. So I've got the picture of this Honda Accord here because that was really one of the first vehicles that Honda came out with their 1500 MPa steel. Primarily in the A-pillar reinforcement, B-pillar reinforcement, rocker panel reinforcement, and pretty much all late model Honda vehicles now have 1500 MPa material in the side aperture of the vehicle. In addition, the Honda Civic also is using 1500 MPa steel for the rear rails. It's got a sacrificial crush can in the back, but the majority of that rear rail on the Civic sedan, not the coupe, but the sedan is 1500 MPa steel. The same rules are going to apply for this as applies for the other ones, which we'll get to in a moment. And I put this Mazda 6 in here because Mazda is now using 1800 MPa tensile strength steel in the side aperture of their vehicle. So we keep going higher and higher, stronger and stronger, and it's only going to continue in that way. So back to the Honda. So one thing that we've done is we've got a fantastic relationship with Honda. We have a lot of their body repair news articles available on the RTS portal. So if you come to rts.icar.com, click on OEM information, then click on the Honda logo. You'll bring up a bunch of information, including their body repair news publications, which are fantastic. They release one for every new model that they're coming out with. And it's got a lot of good information about the material identification on the vehicle, what you can and can't do to some searches in certain situations, and even some information on MIG brazing, which we're going to touch on momentarily. Specifically, Honda states for the 1500 MPa material, whether it's the side aperture or the rear rails on the Civic, no straightening. If the 1500 MPa steel is damaged, you're replacing that part every time. No sectioning available as well. The only ultra high strength steel section that I can think of is Volvo for some of their boron steel B-pillar reinforcements. They still allow that, but Honda says absolutely no sectioning, must be replaced at factory seams. Squeeze type resistant spot welding, again, essential tool, is the preferred method, but there are a couple of locations on the lower part of the B-pillar and the upper part of the B-pillar, for example, that you can't get two-sided spot welding access to. In those cases, we require MIG brazing. So MIG brazing is going to become kind of our next attachment method that we're going to have to start getting familiar with or more familiar with, making sure that we got the equipment, making sure that we got the tools, making sure that we've got the training available, that we understand how to go through the MIG brazing process. So MIG brazing is a non-fusion process, so we're keeping a lower heat effect zone on this. We're also damaging less of the OEM corrosion protection that might be there as well. But the capillary action of MIG brazing creates for a very strong joint. We've done a lot of testing on it, and if you've got the proper fit up and the proper preparation, the proper technique, that capillary action can create a joint that's just as strong as conventional fusion welding. Very similar characteristics from a strength standpoint, as you can see here. As far as equipment goes, a lot of vehicle manufacturers, Honda in particular, does require pulse spray for their MIG brazing procedures on their vehicle. Volkswagen says you can use short circuit or pulse spray. Other vehicle manufacturers are kind of in between, and I do believe Jaguar Land Rover is currently updating theirs. You're going to be using 100% shielding gas on this. So here's a few vehicle manufacturers that have MIG brazing recommendations. Again, Honda is definitely leading the way in this area. General Motors, now we're starting to see a lot more MIG brazing on General Motors. The Chevy Bolt, the Chevy Cruze have got some MIG brazing procedures on them. In fact, the lower rail on that Bolt, I believe, has got It's got MIG brazing, it's got rivets, it's got spot welds, it's got adhesives. So pretty much every attachment method under the sun is done on one particular part on that vehicle. Jaguar Land Rover uses it in a couple of locations. They may be going from pulse spray requirement into a short circuit transfer requirement or allowance. Again, Volkswagen does allow others to do it. And there will be more to follow for sure. But you should only use it where specified. So don't just arbitrarily decide, you know what, I like this MIG brazing, it's lower heat, and only use it where the vehicle maker recommends. Again, following those vehicle maker procedures is important. Some of the joints that we're going to be doing, open butt joints, is going to be not done very often in the North American market. We're more likely to be using the slot welds like we see on the top, or the Honda procedure calls for 2 plug welds that are placed adjacent to each other. And what you do with this one is we're using the push technique with our 100% pure argon shielding gas, and we're going to go and do a zigzag pattern on this particular weld. So one of the ways that capillary action and that MIG brazing gets that joint is through that capillary action is it's got more surface area to grab onto. So that's why we use a slot weld. That's why we would use a double plug weld like this to get more surface area for that joint. When it comes to fit up and preparation, one thing to remember is to not over clamp it. If we over clamp those panels together, we can't. The MIG brazing doesn't get that capillary action. It's got nowhere to go because the fit up is too tight. So we need to make sure that we don't over clamp it. You have a good root gap in our open butt joints. So again, we don't want them butted right up against each other. We want to have a little bit of a gap there so that capillary action is allowed to take place. When it comes to weld-through primer, that's one question we've gotten. We held a repairability summit and developed and published an inter-industry developed and vetted best practice that says unless the vehicle manufacturer recommends otherwise, don't use weld-through primer when MIG brazing. Removes paint coatings in the area. So again, this best practice is also on the RTS website. I'm not going to go through and read every word on here for you, but again, those are resources that are available at your fingertips if you so need them. ICAR has developed a MIG brazing hands-on skills development course. It's available in the Canadian market, so certainly look into that if you've got technicians that are ready to get on the MIG brazing bandwagon and you invest in the equipment. Take a look at that course. It's a fantastic course. It kind of goes through how to set the machine up, how the differences between spray versus pulse. Between short circuit and spray pulse. And so it gets a fantastic course. It's readily available now. And take a look at that if you get the opportunity to. Okay, aluminum. Don't want to spend a lot of time on aluminum. It's been pretty obviously a hot topic with the F-150 and other vehicles that are out there. But I do want to share a couple pieces that we've been working on lately. So when it comes to the dedicated repair area and aluminum clean rooms, the OEM requirements do vary. Certainly Audi's got their repair bay, and a lot of the other vehicle manufacturers have recommendations for curtains. Because of galvanic corrosion and because of explosive dust. We've been working with the Aluminum Association for the past couple of years doing some research studies on the explosivity of aluminum dust. Aluminum dust in the right concentration, airborne, the right size of particles, and an ignition source absolutely will explode. So will steel dust. So will powdered sugar. We believe that while good hygiene and safety are paramount, some of the concern around aluminum dust explosivity may be a bit overstated, which is okay because again, we want to be safe. Even more overstated though, I think, is the galvanic corrosion part of it. F-150s have had aluminum hoods since 1998. Did we take the hood off the F-150 and bring it to its own room every time we would repair a dent on it? Did we get different tools every time we had to do it? No. Have any of those come back because of galvanic corrosion, because of the same hammer that we used on a steel panel, we used on an aluminum panel and embedded a piece of steel in there and now the hood is rusted away? Not very likely because we're cleaning it, we're putting protective coatings on it. For galvanic corrosion to take place, you need dissimilar metals, first and foremost. So if you got aluminum steel, that will obviously corrode. You need moisture and you need air. Well, if we take away the moisture and the air from those particles, the chance of it being, especially if we clean it, is good as well. The potential for galvanic corrosion is probably quite minimal. We recognize fully that we're probably not going to change Audi's mind anytime soon or some of the vehicles, but for that next generation of vehicles that come out there, maybe we could have some different guidelines. And that's one thing that we're working on the RTS team to do, is bridge that gap between the OEs and the collision repair industry and try to share this information. So again, this is a scientific study. We compared steel and aluminum samples, and the document should be published here in the not too distant future. So again, keep an eye on out for that. But again, we're thinking that maybe some of these things are overstated, especially when you start looking at some of these mixed material vehicles. Well, where do I repair a Cadillac CT6 that's got steel and aluminum? Where do I repair a Porsche 911 that's got steel and aluminum in the structure of it? So again, the practicality of it may not be make sense for us to do this in the future. Rivets, similar to MIG brazing, we're going to have to get familiar with rivets, self-piercing rivets, solid rivets, blind rivets for different applications. It's not going to be just for aluminum vehicles. It's going to be for those future mixed material vehicles as well. And as luck would have it, of course, ICAR does have a hands-on rivet bonding course that's also available on the Canadian market. So take a look at that. Reach out to ICAR for information on that. Again, a fantastic course. Come in your shop, work with you on that, and to get that course done. Again, we're going to be using this technique in the future quite often, along with MIG brazing and others, because we're going to start seeing a lot more mixed material vehicles. The days of, well, this is a steel vehicle and that's an aluminum intensive vehicle, I think are going to be going away. The material engineers are going to use the material that they feel is best for that particular application. So you may have an inner B-pillar that's made of aluminum, that's got a carbon fiber reinforcement with a steel outer that's all rivet bonded together. I think that's going to become the new norm in the future is, again, mixed material vehicles. And we're going to have to get familiar with it and identify which materials we're working on, what are the repairability guidelines, can I straighten it, can I not straighten it, and then certainly attachment methods, because we can't spot weld these vehicles back together, we can't MIG braze these vehicles back together. We're going to have to use alternate joining methods such as rivet bonding. Okay, a little bit about the ICAR Repairability Technical Support Initiative here to close out. The RTS initiative started around 2014, and we formally launched our RTS website in June of 2015. The RTS initiative is really comprised of 4 key elements. The RTS portal, our website, that's our main distribution. That's where we share a lot of the content out there, and we've got about 50,000 plus pages of content for the industry. Our industry and OEM linking pin, so again, that connectivity between the collision repair community and the vehicle manufacturers. We've always kind of done it informally in the past, but we've been doing a lot of OEM linking pin issues. Since we launched the website, we've escalated 250-ish, 270 questions to the vehicle manufacturers looking for clarification, things that we found in a body repair manual that weren't accurate or were contradictory, procedures that weren't there that we thought, hey, there might be a repair opportunity for this. Of those 270, we've closed out 250 of those escalations. So through the RTS initiative, we're working with those OEMs to share information and try to close some of those gaps in information that are out there. The bottom right are OEM and our tool and equipment technical advisory councils. We sure love our acronyms in this industry, don't we? Those are bringing vehicle manufacturers together, bringing tool and equipment manufacturers together, and talking about topics that are facing the industry. What's coming next from the vehicle manufacturers? What should we start thinking about looking at developing for new courses, for new repair information? Same thing with tool and equipment manufacturers. What are you guys hearing on the tool and equipment side that we can start leveraging and start looking at? At the same time, it affords us the opportunity to provide feedback back to them. So as we're meeting with the vehicle manufacturers, the tool equipment manufacturers, if we've got collision repairers out there saying, I really wish there was a widget for this particular repair application, we can then go back and share that with the tool and equipment community and hopefully develop some solutions around that. And then the last piece is our repairability summits. Repairability summits are kind of the driving force behind the ICAR best practice that we've been developing. We bring in subject matter experts to talk about a particular topic and come up with solutions. So again, when we did our MIG brazing one, we brought in welding manufacturers, we brought in vehicle manufacturers, we had some insurance personnel there as well that has some expertise, and we developed the best practice with industry input on it. With the collision repair diagnostic summits we've been doing, it's been Aztec, it's been Snap-on and Bosch and the vehicle manufacturers and other subject matter experts coming in and telling us what we should do from a best practice standpoint. So those repairability summits, we do on average maybe 2 to 4 every year around a specific topic that eventually turns itself into an ICAR best practice potentially, collision repair news article that we develop and deliver, or it may make its way into an ICAR course at some point as well. So again, the RTS portal, we've got a lot of information on this. Like I said, 50,000 plus pages of content probably today. We've got our quick search by vehicle, so you can put make, model, and year right on the home page. It'll pull up everything that we've got in our database on that particular vehicle. We've got a lot of information on OEM information, which I'll share with you momentarily. Collision repair news. Every week we're publishing a minimum of 5 collision repair news articles. Just little snippets that we've learned. So, for example, we found out 2 days ago that Ford's updated their steel repairability matrix. That was an article that we published yesterday, letting the industry know, hey, things have changed. There's a new document. Refer to it instead of the old document. If we find out about a new vehicle, it's got new materials on it, we'll share it through the collision repair news articles as well. So a lot of good information. Again, all free to the industry, and that one doesn't require even a login. So those articles, you don't have to log in or go through the international entrance. Our OEM calibration requirements, I already touched on that. Our OEM partial part replacement. Again, we've invested thousands of hours so that the industry doesn't. So if you're wondering, is there a sectioning procedure available for a 2015 Chevrolet Malibu? Well, log into RTS and look there rather than trying to find it in the OEM information. We'll say, yes, there is, or there's a partial part replacement at factory seam, or there's no sectioning information available. Now, again, as you're building a repair plan, putting together that damage assessment, you can put, for a complete part replacement. We've got hybrid disable switches, or hybrid disable information, glass replacement. We've done a series of articles on glass replacement, so we've got every vehicle manufacturer's recommendations for what they require for pinch weld preparation, adhesives, etc. And then Ask iCar, that's one of the features that isn't currently as available in Canada, so we don't have the ability to pick up the phone and answer those questions, but you can still go on there, log in, and see questions that have been answered already. The big part of it, I think, from a resource standpoint, that's most valuable to the industry really is, in addition to those collision repair news articles and the matrices, is the OEM information. So we've worked with the vehicle manufacturers to help distribute their information. Now we don't have all the body repair manuals in there. We don't have licensing agreement for that, but a lot of those documents, like that Honda body repair news, those are available. Ford sends us instruction sheets on the F-150 and the Super Duty vehicles for the aluminum. Again, it's a conduit for them to share. Obviously, they've got connections with their dealership. They've got connections with their certified collision repair network, but they don't have all the masses. They don't have all the independents that aren't part of those networks. So they've been leveraging iCar to share that information. As you can see, we've got a lot of, now obviously, some of the vehicle manufacturers have a lot more information than others, but there's a lot of good information. From there, we've just got listed on each of the vehicles. I pull up Ford here, for example. I can see we've got F-150 and Super Duty repair instruction sheets. We've got links out to the Ford Collision Repair website. We've got links out to the Ford consumer side of things. So if you want to look at a vehicle manufacturer's lineup, or you've got questions about trim level or anything like that, that information is available. Position statements, the repairability, steel repairability guides. And then one thing that is another novel idea that one of our team members had was because no two OEM websites are alike, it's hard to find information because Ford puts things in a different location than Toyota, which is different than Fiat, Chrysler, et cetera, et cetera. So what we've done is we've created videos on how to, number one, get a subscription to an OEM website, and then how to find the information you're looking for. And I use this all the time. For the walk around that we did last night, I have not spent a lot of time in Subaru collision repair manuals. So I didn't know where to look, so I pulled up this website yesterday. I looked at the step-by-step instructions, and I was able to find what I was looking for much more quickly than if I was trying to rely on it myself, because a lot of the times the vehicle manufacturer will have it'll say body repair information. Well, the body repair information or a lot of service information is door removal, fastener removal. It doesn't have collision repair information. You need to look in a different section. So again, leverage this tool if you're really looking to find that information. And then what we've done is we've made it easy to print. So you can click on a downloadable PDF of it as well and print that, put it in a binder, put it next to your computer so that the technicians or estimators, whoever needs it, can access that document and find that login information more quickly. Just a couple real quick, we've really been growing this RTS portal pretty quickly. 274,000 page views in 2017. We've got 55,000 users that are using it. Right now, in the US alone, we've got about 110,000 people that have access through their iCar Platinum individual status, iCar Gold class, again, and it's all available to Canada as well. And actually, Repair Driven News did a survey asking where people go for OEM information, and we had quickly jumped up the #2 source behind all data. And again, we don't have anywhere near as much, actual collision repair, body repair manuals as all data. We're just again providing that conduit. But if we say it's available, then you can leverage all data or the OEM to find that information in there. So with that, I appreciate the opportunity. I got through all that quickly. I wasn't sure if I was going to be able to do it, Patrice, but we did. So I do thank you. Again, it's an honor to be back here, and look forward to returning someday.